problem is about gravity. The question is, well, it's about gravitational energy, I guess. The question is, at what height above Mars's surface would you have to put a satellite so that the amount of energy you'd need to lift it is equal to the amount of energy you'd need to give it for its orbital energy? Okay, so we're talking about giving it energy both to lift it up and to get it moving fast enough, and at what point, what height are those going to be equal? Well, we know that gravitational potential energy is equal to negative G, big M, little m, over R. Right? We also know that the force of gravity, which is Gm m over R squared, has to be equal to, or has to be equal to the centripetal force of this thing for it to stay in a proper orbit. So that has to equal mv squared over r. Alright? We also know that kinetic energy is 1/2 mv squared. So, we solve for all these things. We solve for v squared here. Okay, we get rid of that. Get rid of the mass and the mass. We get that v squared is equal to g m over r. We can then plug that in here, and we get kinetic energy is equal to 1/2 g m over r, which, as you can see, is half of the potential energy. Now, we want to get these two to be equal, except that we don't actually want these two to be equal. We want kinetic energy to be equal to the change in U. And the reason we want that instead of just U is because the potential energy is based on the radius from the center of Mars. We want it from the surface of Mars because we're starting at the surface of Mars. We're looking at the satellite from the surface as opposed to from the center. So change in U is going to equal to U final minus U initial. Alright? Now, how that ends up to be is that we have 1/2 G m over R is going to be equal to U final, which is negative G m over R, plus G m over the radius of Mars. The reason it's plus there is it's negative or negative. It's minus the negative. Turns out we know the radius of Mars is 3397000. So let's take that. Bring it over here. Okay, again we have G, that's probably too hard for you guys to see. G m over 2R is equal to negative, well, let's go positive, G m over 33970 minus G m over R. Okay? We can put this on, first of all, we can cancel out the G's, little m's, big M's, and we get 1 over 2R equals 1 over 33970 minus 1 over R. We switch this around, we get 3/2. 3 over 2R is equal to 1 over 33970, and that's, I lost a 0 somewhere from down there. And what should get is that R is equal to 1698500 meters, or 1699 kilometers. That's how high you would have to rise any object to get it. And you notice it's any object because we've managed to cancel out the mass. of both of them. In fact, this is for any object with the radius of Mars. It doesn't matter if it's more massive than Mars, less massive than Mars. It's only dependent on the original radius.